Scientists are stunned after the James Webb Space Telescope discovered 7 massive structures at the edge of the observable universe. What precisely are these massive structures? Did scientists discover the edge of the universe? Is there a new world out there? Join us as we go to the far reaches of the universe. Despite everything we've discovered about our universe, many existential issues remain unresolved. We don't know if our universe is limited or infinite in size. All we know is that it must be larger than the area we can see. And we still don't know what happened in the beginning, in the first minuscule fraction of a second of the scorching Big Bang, because we don't have enough evidence to reach a firm conclusion. But one thing is certain: the universe has an advantage, not in distance, but in time. Because the hot Big Bang happened at a known finite point in time, 13.8 billion years ago, with an uncertainty of less than 1%, there is an edge to how far away we can see. Even at the greatest cosmic speed limit, the speed of light, there is a basic limit to how far back we can see. The further we look, the further back in time we can see. Here's what we view as we near the universe's edge. But how did the James Webb Telescope detect 7 massive structures at the edge of the observable universe? The Hubble Extreme Deep Field was built using a section of the previous Hubble Ultra Deep Field image over the span of 50 days and over 2 million seconds of total observing time, the equivalent of 23 full days. The XDF represented humanity's deepest view of the cosmos, combining light from ultraviolet through visible light and out to Hubble's near-infrared limit, a record that stood until JWST destroyed it. In the red box, where Hubble sees no galaxies, the JWST's Jade Survey discovered the farthest distant galaxy to date, Jade's GS-Z13. We infer a total of 2 sextillion stars within the observable universe by extrapolating beyond what we see to what we know and anticipate to exist. The James Webb Space Telescope is an infrared observatory that orbits the Sun about 1 million miles from Earth in order to discover the earliest galaxies that formed in the early cosmos and to observe stars developing planetary systems. Webb will investigate every stage of our universe's history, from the first brilliant glows after the Big Bang through the emergence of solar systems capable of supporting life on planets such as Earth, as well as the evolution of our own solar system. It will expand on the discoveries made by the Hubble Space Telescope. The JWST, which is now fully operational, has 7 times the light-gathering power of Hubble, but will be able to see much further into the infrared portion of the spectrum, revealing galaxies that existed even earlier than Hubble, due to its longer wavelength capabilities and much lower operating temperatures. Prior to the epoch of reionization, galaxy population should be abundantly identified, and Hubble's previous cosmic distance record has already been shattered. The JWST Advanced Deep Extragalactic Survey's annotated rotating image shows off the new cosmic record holder for most distant galaxy, Jade's GS-Z13, whose light reaches to us from a redshift of Z equals 13.2 and a time when the universe was just 320 million years old. Although we are seeing galaxies at greater distances than ever before, these records will most likely be broken when more serendipitously aligned gravitational lenses are discovered, as well as when longer observing times with JWST are leveraged. The JADES and JWST NIR-SPEC spectra for the 4 most distant galaxies discovered so far by the Jade Survey. The Lyman break feature, which has been robustly found for each of the 4 galaxies, establishes the distance and redshift beyond a reasonable question, making Jade's GS-Z13 the current cosmic record holder for the most distant galaxy. The Atacama Large Millimeter Submillimeter Array is a radio telescope array. The array has the light-gathering power of the sum of the collecting areas of the individual dishes, but the resolution of the distance between the dishes. It can distinguish molecular signatures that absorb or emit at long radio wavelengths, as well as infrared signatures released at great distances and redshifted within Alma's sensitivity range. It achieves resolutions high enough to map out gas and gas characteristics, even in the most distant galaxies. Alma can identify some of the most distant ionized excited elements in cosmic history due to its views that extend beyond the limitations of infrared astronomy, but are sensitive to spectroscopic signatures. Galaxy GHZ2 Glass Z12 is determined to be one of the brightest, most UV-rich galaxies from the early universe, as well as one of the most distant ones yet observed, based on the distance validated by Alma. Astronomy is similar to a community. We gather around and eagerly await our elders to weave complex stories about our history and origins, filling us with purpose and awe. And while these ancient tales may seem stuck in time, they always provide valuable insight into future endeavors. This is why astronomers have worked feverishly to probe as far back into the observable cosmos as possible. Bringing in the James Webb Space Telescope as a battering ram aided our efforts to chip away at the universe's built-in protective walls, and the observatory has certainly done its part. A group of astronomers was recently sifting through early JWST data when they discovered something quite fascinating. They discovered 87 galaxies that were so redshifted that they could very possibly have been among the earliest galaxies to form after the Big Bang. Deep field photographs collected by the James Webb Space Telescope during its early observation campaign appear to be scattered with galaxies nearly as large as the Milky Way and full of adult red stars, giving astronomers a headache. This image, captured by the James Webb Space Telescope, shows thousands of distant galaxies and covers an area of the sky that is only 2% the size of the full moon. The image's faintest objects are nearly 1 billion times fainter than what the naked eye can see. This is known as a medium-deep, wide-field photograph. Light from the furthest galaxies has taken nearly 13.5 billion years to reach here. When the light-emitting source moves away from the viewer, light frequencies tend to extend towards the redder region of the visible light spectrum. Simply put, the more red the light seems, the older its source. And, much to the chagrin of any therapist, scientists are continually on the lookout for similar red lights in the universe. The issue was that the oldest bodies were so redshifted that they bled into the infrared spectrum. Unfortunately, this was beyond the capability of Webb's predecessor, the Hubble Space Telescope. These galaxies, revealed in a recent research based on Webb's first data release, are so far away that the powerful telescope only sees them as tiny reddish dots. However, study of Webb's data revealed that these galaxies were born barely 200 to 400 million years after the Big Bang, at a time when the universe was still extremely young. Such early galaxies are not remarkable in and of themselves. Astronomers predicted that the first star clusters would form soon after the universe emerged from its so-called dark ages, the first 400 million years of existence when space was filled with a dense fog of hydrogen atoms. However, the galaxies identified in the Webb photos were astonishingly large, and the stars in them were far too ancient. The unexpected discoveries contradict established theories about how the cosmos appeared and evolved in its early years, and also contradict previous observations obtained by Webb's less powerful predecessor, the Hubble Space Telescope. In general, young stars shine a vivid blue. As stars age, their glow becomes redder as they burn up their fuel and cool. Astronomers had not expected to see old red stars in the ancient galaxies that Webb was designed to observe. They also did not anticipate finding galaxies larger than 1 billion suns. However, the reddish spots seen in Webb's deep fields appear to be 50 times larger, Leja said. Before astronomers start rewriting cosmology theories to explain how these galaxies got together so rapidly after the Big Bang, Leja says they need to make sure the strange red dots they're seeing aren't anything else. The majority of the alternate answers, however, require whole new concepts, according to Leja. Webb's near-infrared camera captured the photos that revealed these perplexing galaxies as part of the Cosmic Evolution Early Release Science Program. Astronomers intend to return Webb's mirror to these galaxies soon in order to get light spectra of those faraway spots. Spectra deconstructs observed light based on its wavelength composition, revealing the chemical and physical features of its source. However, there are numerous edges to the universe: the edge of transparency, the edge of stars and galaxies, the edge of neutral atoms, and the edge of our cosmic horizon from the Big Bang. We can view as far as our telescopes will allow, but there is always a basic limit. Even if space itself is infinite, the length of time since the hot Big Bang is not. There will always be an edge that we will never be able to see past, no matter how long we wait. Curious to know more about it? Then subscribe to our channel and join us as we explore the universe. The James Webb Telescope just proved the Big Bang Theory wrong. Unbelievable, right? Watch the end screen video to know more. We will see you all there.